The Sun, our big, glowing hydrogen bulb, sits at the center of the solar system, beaming light onto our path and supporting life itself. But what if we poured a gigantic bucket of water on it? Would it go off? Or what kind of fate would we suffer? As crazy as it sounds, the consequences would be beyond your wildest dreams. Let's tell you the story. The Sun is one of the over 100 billion stars contained in the observable universe. However, this gigantic flaming ball of fire is no ordinary star. It's the most sizable object in our very own solar system. According to scientific data, the Sun makes up for 99.8% of our solar system's mass. For perspective, it weighs about 500 times more than all the planets and asteroids in the solar system combined. Ironically, the Sun doesn't have a solid mass, and it doesn't have obvious boundaries like the rocky planets in our solar system. But like everything that exists within the universe, the Sun was formed from a rapid collision of gases and dust, which happened around 4.5 billion years ago. These gases actually exist in the form of plasma, which is literally still a gas, but with ionized particles. It is almost entirely made up of hydrogen and helium and split into different layers. In addition, the Sun's diameter is about 109 times that of the Earth's. At the same time, it's more than 5,600 times heavier than our planet, meaning over 1 million Earths could fit nicely inside the Sun. In fact, the Sun is responsible for supporting the entire solar system. It provides the gravity that keeps everything within the observable universe in its natural position, from the tiniest bits of debris to gigantic celestial objects like Jupiter. The Sun spins around on its own axis just like Earth, rotating clockwise for between 25 and 35 days to complete a single rotation. It also orbits clockwise around the center of our Milky Way galaxy. It moves clockwise around 24,000 to 26,000 light-years away from the center of the cosmos. One such trip takes about 225 million to 250 million years. On average, the Sun is about 93 million miles away from our Earth, meaning sunlight needs around 8 minutes and 19 seconds to reach our planet. The Sun's surface temperature is around 5,500 degrees Celsius, which is equivalent to 10,000 degrees Fahrenheit. However, temperatures at its core could reach 15 million degrees Celsius or 27 million Fahrenheit. According to reports, the star has a mass-energy conversion rate of 4.26 million metric tons per second, producing around 385 trillion watts of power, which is more than 10,000 times the world's total energy use. To generate this much energy, you need to explode around 100 billion tons of dynamite every second. Contrary to popular belief, the Sun is not a ball of fire. It doesn't burn in the way we think. But of course it glows, thanks to a process known as nuclear fusion that takes place at the center of its heart. In simple terms, the nuclear fusion is when one proton smashes into another proton so hard that they glue together to produce the same amount of energy. Consequently, this energy heats up other elements like protons and electrons around the reaction. As the process continues, the heat spreads out through the center of the Sun to other layers before radiating into outer space and, consequently, to the Earth's atmosphere. Scientists often suggest that the Sun burns hydrogen to produce light, but in reality, that's not the case because hydrogen doesn't exactly burn. Instead, it fuses into helium in a process that doesn't require oxygen. Although it's located hundreds of millions of kilometers away from Earth, the Sun has a hugely influential role in everything that happens on Earth. It controls our weather and climate, ocean currents, seasons, and the process of photosynthesis, which supports plant life by radiating light, heat, or solar energy. This light helps plants to grow, and animals, on the other hand, need plants for food and the oxygen they produce. This process is also essential to support all animals and humans on Earth. Critically, our planet would freeze if we did not receive heat from the Sun. However, it also poses a huge threat to our existence. The Sun has some extreme and powerful eruptions, where it discharges steady streams of charged particles into our atmosphere. This phenomenon is known as a solar flare. According to scientists, solar flares are the most violent eruptions in the solar system. A single solar ejection or wind can launch approximately 20 billion tons of matter into space, moving at a speed of approximately 6 billion miles per hour. These solar winds pose a threat to our technological infrastructure, including satellites and power grids, which could send us back to the Stone Age. So it's clear that the sun is capable of causing extreme situations. But what if we poured a gigantic bucket of water on our home star? Well, first off, that would be a Herculean task. To start with, you would need the equivalent of 2 million Pacific Oceans to fill the entire volume of the sun with water. Now, let's do the numbers. One Pacific Ocean has a volume of about 700 million cubic kilometers of water, which ultimately means you'll need 141 sextillion cubic kilometers to fill the sun. That shouldn't be difficult because science tells us that water covers 70% of the Earth. But unfortunately, our planet doesn't have enough water to put out the sun. In fact, if we combined all the water in the oceans together and added it to the water below the Earth's surface and everywhere else, including the water in your tank, the maximum volume of water we'd get is approximately 1.3 billion cubic kilometers. But even if you do get the imaginary 141 sextillion cubic kilometers of water needed to fill the sun, you'd still run into other problems. There's a problem of transporting the water 93 million miles from Earth to the region in space where the sun is located. And then your imaginary bucket would need to be protected by a heavy shield, robust enough to survive the fierce temperature of the star. But even if you did put all these things in place, you still wouldn't be able to quench the sun because, as we mentioned earlier, the sun isn't a burning ball of fire. Rather, it's a glowing ball of nuclear fusion, meaning it literally cannot be put out with water. But for the sake of this video, what if you poured water on the sun? Would that be enough to kill a star that has lived for over 4.5 billion years? Well, not exactly. Ordinarily, we should start from humble beginnings and explore what would happen if you threw a single bucket of water at the sun. But we all know what the outcome would be. The water and the bucket will add to the fuel that will make the star glow even brighter. So what if you get a big tank of 141 sextillion cubic kilometers of water and get firefighters to directly deliver it to the sun? The results shouldn't be any different, except the consequences will be much more deadly. The water will evaporate the second it nears the sun's atmosphere. If you continue the process, the water vapor would eventually be broken down to become hydrogen and oxygen. Within 30 minutes, the hydrogen and oxygen molecules will leak slowly into the center of the sun and will eventually be converted to plasma at a minimum temperature of 33 million Kelvin. But here come the consequences. The sun's density is about 40% higher than that of water. So, in literal terms, a bucket of water equivalent to the volume of the sun will weigh about 0.71 times the mass of the sun, or 0.71 solar masses. After offloading it, the sun's mass will increase to become 1.71 solar masses, with a composition of 48% hydrogen, 37% oxygen, and 14% helium, with around 1% heavier elements. If this were to happen, the mass of the sun will increase its energy output by 16 times, meaning it will shine 16 times brighter. So in other words, throwing water on the sun would only give it more fuel to burn. Without a doubt, the consequences would be fatal for us. Our planet would burn instantly, and even Pluto would be like hell. In reality, only 5% of the mentioned quantity of water would be enough to wipe out our species and make our beloved Earth inhabitable. Should this happen, we would witness so strong solar flares like back in 1859 when the Carrington event took place and left a memorable scar on our planet.